Hello! In this video, you will see how to use MCUXpresso Config Tools from NXP together with Keil MDK projects. MDK Pack Installer tool contains the list of all NXP devices supported by MDK. The support is based on TEMS's device family packs, which are maintained by NXP for most of their Cortex-M-based microcontrollers in Kinetis, IMXRT, and LPC families. For my demo, I will use IMXRT 1050 EVK board and can also find it in the Boards tab. Note that not all development boards might be defined in the packs. In such case, you can go to the Device tab and search for the target microcontroller. We can see that NXP provides the DFP pack to support IMXRT 1052 device and also a BSP pack that contains board support package and multiple examples. I have the packs already installed in my environment, so let's switch to Examples tab, where we can find all application examples provided for the target device, and I will start with the sanity check example available for most NXP devices. I let Blinky. Press Copy button next to it, specify the target folder, and by default it also gets automatically launched. Microvision project may contain multiple targets that specify different configurations. I choose the target for execution in SDRAM with debug enabled. In the project, we can see a board support component that contains the SDK project template files. They configure not just the board, but also device clocks, peripherals, and pins. MCUXpresso Config Tools can be used to update the code in these files, so it is important to have this component present. It can be easily added from Manage Runtime Environment. Then, under Board Support Group, we need to have the SDK project templates selected. Several variants might be available. In my case, I keep the variant for the evaluation board. The SDK template files rely on SDK driver APIs to configure the device, so the drivers for target peripherals need to be present in the project as well. Here we have already enabled the drivers for clocks, common components, GPIO, pin multiplexing controller, UART, and others as required by the application. Now I will go ahead and modify the device configuration in this project. In MCUXpresso Config Tools, go to menu File, New, and select the option to create a new configuration based on existing IDE project. Here we need to provide the path to our Microvision project. Here it is, and click Finish. After some time, the configuration view opens. It automatically picks up current configuration from the SDK template files located in the project. So, for example, in the pins view, we can see that a pin F14 is configured for GPIO 1 signal, as it is used by the application for toggling user IDs. In the clock tool, we can see that the CPU frequency is set to 600 MHz, and that can also easily change it. For example, let's just reduce the prescaler so that the frequency is set to 300 MHz. Okay. When configuration is done, just click on Update Code button. The tool shows what files will be updated to apply the changes. In my case, this is just the clocks related files. We can also see that it has created a config file with a .mex extension. This file can later be used to open the project configuration in MCUXpresso Config Tool. Now the configuration code is updated, And after switching back to Microvision, I also see a notification that the clock config file open in the editor was updated externally. In the project directory, we now can find the generated configuration file for MCUXpresso Config tool, and in the board support folder with the configuration code, we also can see the backup files with the previous clock configuration, in my case, that can be used to get the settings back if anything went wrong. Before building the project, I need to make additional change. I know that SD RAM targets, in this example, have an extra C file related to flash boot. It is not needed for SDRAM and just leads to a linker error. So I just exclude it from the build. With this change, the SDRAM target in this project builds without errors and warnings. For debug, I use Ulink Plus debug adapter that is able to measure the actual CPU frequency. Now, when starting the debug session and opening System Analyzer, we can see that the MCU runs at 300 MHz as was configured by MCUXpresso Config tool. This was a simple example on how to use MCUXpresso Config tools together with Keil MDK. MCUXpresso documentation describes in details all device configuration possibilities. On our website keil.com/nxp, you can learn more about the support of NXP devices in Keil MDK. Thank you for watching this video.